Let's look at part C here. Part C says the integral of dx over the square root of x squared minus 1 here. Again, in part A, we use the inverse trig substitution. We couldn't use that here because we don't have that x in the denominator. Part B, we used u substitution because we had the x in the numerator and we knew that it would simplify out. Part C here, in all honesty, this is like the integral. This is the integral of 1 over the square root of x squared minus 1 squared dx, right? So if we looked at this, this would be the integral of 1 over the square root of u squared minus a squared. And this would be a du is really what it is. This is not possible to integrate. With our rules. Remember, we need that the u out in front is what you need to make it match the rules. So you absolutely could not do this to solve this problems. So you must use technology. Or a table. Integration table to solve. So what's the moral of the story? X on bottom is the inverse trig sub. X on top, traditional u sub. No x makes the problem impossible. Such a small difference between these problems and you're just absolutely done. Absolutely done. So this obviously wouldn't be on the test. I just wanted to emphasize it for you as the book does because they cover this problem. This is not a problem you can solve. So you just need to be really comfortable with these different techniques, okay? So let's look at example 5. Example 5, again, it's just showing us what's the simple way to do these problems. So A says the integral of dx over x ln of x. Notice both x and ln of x are on the denominator. B has the natural log of x on top and x on the bottom. And C just has the natural log of x. So 3 very similar problems with 3 very different approaches. Okay, let's see those different approaches right now. Again, 5a, this is a problem that we did in the previous section, in section 5.7, but let's remind ourselves the trick on this problem. The trick on 5a, which is the integral of dx over x ln of x, the trick on this was to let u equal the natural log of x. Step 2 would be find the derivative of u with respect to x. Well, the derivative of the natural log of x is 1 over x. Step 3 is solve for dx. So dx would actually be, because we'd multiply both sides by x and divide and dx, so dx would actually be x du if you're careful enough with that. We're going to substitute in for dx, and we're also going to substitute in for u. We rewrite our integrals, so this is step 4. This would be the integral of, instead of, I'm going to write this as 1 over x, natural log of x would be u, and then dx would be x du. Notice those x's simplify, and so we're left with the integral of 1 over u du. We can integrate that. We know the integral of 1 over u du is the natural log of the absolute value of u plus c. The only thing we have to do is back substitute for u. And so that's step 6. So we end up with natural log of the absolute value of u, which was natural log of x, plus c. And that's our final answer for part A. So if you have the integral of dx over x times the natural log of x, use u substitution with u equal to natural log of x, you end up with natural log of the absolute value of the natural log of x plus c. Great test problem right there. Let's notice the difference between that and B here, okay? What's the difference between this and part B? B says the natural log of x dx. Well, this is the same style problem here. Let's continue with let u equal the natural log of x. And then step 2, again, find the derivative. So du dx, in this case, would be 1 over x, because the derivative of natural log of x is 1 over x. Again, step 3 would be solve for dx, and that would be x du when you multiply both sides by x and dx. We're going to substitute in for dx. Sorry, let me get the right color. We're going to substitute in for dx, and we're going to substitute in for u. When we do that, we end up with step 4, which is rewriting the integral. The integral would be u over x, and this would be times x du. Notice the x's simplify here, and we end up with the integral of u du, which is easy enough to use the power rule on. The integral of u du would be u squared over 2, or 1/2 u squared, plus c. The only thing to do left on that is to back substitute for u. So when we back substitute for u, that would be equal to 1/2 times u was the natural log of x plus c. Sorry, that has to be squared, right? Natural log of x squared over 2 plus c. So that's our final answer on that problem. We have 1/2 times the natural log of x squared plus c. Okay. Let's look at the last problem right here. The last problem is integrate the natural log of x dx. Again, here, if you try to use u substitution, your x's would not simplify on this problem. So this is not a problem at this time that we can do. Not something we can do with our current rules. When you go into Calc 2, you're going to learn something called integration by parts. It's like the antiderivative rule for the product rule. You're going to learn integration by parts, and this is a problem that you could integrate by hand. You wouldn't need to use technology. You wouldn't need to use integral tables on this one. This is a problem you can do by hand with something called integration by parts, and that's something that you're going to learn within the first few weeks of a Calc 2 course. But as of right now, this is not something you can do. So this is not something that would be on the test. So very, very simple differences between A, B, and C here, yet very, very different strategies or answers, extremely different answers in these cases. Again, remember, you can always check your answers by finding the derivative of your answers, which you should be doing in each and every one of these problems. But as for now, this is the last section in Calc 1. That was the last problem that we had to do in Calc 1. So you have finished all of your sections, all of your notes, all of your videos for the entire semester up through Calc 1. Very proud of you. Congratulations. Rock your last test and rock that final exam.